Hello everybody, welcome to yet another video by JFB, and in this video I'm gonna explain how we can convert a number from hexadecimal to denary. To carry out this process is actually relatively easy. You just need to remember that hexadecimal is in base 16 and denary is in base 10. That's all. That's the only difference. And like all bases, you start from 0 going up to infinity until you have enough numbers to represent that value. What do I mean by this? Let's convert the numbers which we had in the previous video. If you didn't watch it, there's a link in the description below. You can go watch it right now. We converted 221 to hexadecimal, and that was DD. Then we also converted 1152 from denary to hexadecimal, and that was a 480. So now we're gonna take DD back to where it was and 480 back to where it was. So to do this, there's a simple method of just tabulating the values and multiplying. So we're gonna tabulate values and multiply. In simple terms, we're simply gonna draw a table and multiply. That's all. So let's move on. To convert DD back to denary, it's a very simple series of steps. So we're simply gonna draw a table with two columns. And why two columns? Because DD only has two digits, D and D. That's all. So we draw a table with two columns. That's all. I've included a third extra one, which is practically useless. So then you fill out your table. In the first row, you write your base 16, 16, and 16. Then you increase it in powers from 0, 1, and 2. Then you evaluate this. So this becomes 16 power 0 is 1, 16 power 1 is 16 itself, 16 power 2 is 256. Then you write the number you're trying to convert to D and D. In the final step, you simply multiply this, then you add them. So 1 times D. Now here's where the part is gonna be a little bit confusing. The D is not actually a D from the alphabet. The D is representing 13. So here we're not multiplying D against 1, but instead we're multiplying 13 against 1. To make this more clear, let me not even write D here. Let me write 13. You know where this 13 is coming from? If you don't know where this 13 is coming from, please, I recommend that you watch my first video in this series where I explicitly explained where we get the D's and the A's from. So D is represented by 13. So you can write 13 here and another 13. Then simply multiply 1 times 13, that gives me a 13. 13 times 16, that gives me a 208. Add those two numbers and that's a 221. And as I stated in the previous video, DD was the result of converting 221 to hexadecimal. Moving on to the other example, 480. So how many columns do we need? We need 3 because we have 3 digits. To convert 480, we're gonna need a table that has 3 columns. Why 3 columns? Because there are only 3 digits, 4, 8, and 0. And luckily, there's no letter we're converting to a number. There's no letter, there's no A, there's no D, there's no E, and there's no F. If you don't know where these are coming from, please watch my previous video. So we divide this table further into rows, 3 rows. We need 3 rows. So you start 16, you write your base 16, 16. Then you start 0, 1, and 2. 16 power 0 is 1, 16 power 1 is 16, and 16 power 2 is 256. Placing the number you're trying to convert to, 4, 8, and 0. And all you do is simply multiply. 8 by 16 is 128. 256 by 4 is 1024. 1 by 0 is 0. Then you can simply add now. 1024 plus 128, that will result into 1152. And as I showed in the previous video, that converting 1152 to hexadecimal was 480, and now this time I've converted 480 from its hexadecimal to denary. So that's a wrap of this video. Thanks for watching. Please leave a like, subscribe, and share. Thank you.